So my name is Mark Porter, and I'm very excited to be here today. I am the general manager of Aurora Postgres, RDS Postgres, the RDS platform, which is all that stuff that works across all the engines in RDS, and RDS operations. So how many of you know about RDS? I love it. How many of you use RDS? When it's broken, you'll see my email at the end of the presentation. And I mean that. We take operations and ownership very seriously at AWS. So we operate the largest fleet of databases in the world, and we do it for all of you, and we try to do it in the best way possible. So today, I'm here with my friend, Mr. Tatsuo Ishii-san, who is going to tell you about a bunch of things that he encountered using Aurora Postgres. And he is president of SRA OSS, which is an open source company based in Japan. They are a leading provider of Postgres innovations, such as PowerGres, a fork of Postgres that supplies high availability, more durable replication, built-in encryption, and easy-to-use installation on both Windows and Linux. SRA OSS was founded on the belief that open source software is very important and that building innovations on it while maintaining core openness and compatibility is the right way to go. We believe the same thing at Amazon. We offer RDS Postgres, which is the absolute community version that you expect. We offer EC2 Postgres, which we're very, very excited about. And we offer Aurora Postgres, which is our own fork. So we have kind of compatible cultures here. In addition, I'm very proud that Mr. Ishii-san has been a Postgres contributor for 18 years. So, Mr. Ishii-san, yeah, see, there you go. I feel the same way. So I'm going to start off talking a little bit about Aurora, and then we're going to go on, and Ishii-san is going to come up and talk about what he's done with it. So we're going to do an introduction. We're going to have some performance results. We're going to make a couple of fun announcements with a video and a demo for those of you who are thinking of leaving, and then we're going to do questions. Clicker got a little bit ahead of me there. So first off, what if you were imagining the database today? I have been in databases since 1988, which is a really long time ago. And what if you were to reimagine COD and DATE's vision 40 years later? You'd break apart the stack. You'd build something that can scale out, is self-healing, and leverages distributed services. And you'd use open source software. The world has changed. The time for commercial databases and proprietary APIs is over. You'd build a service-oriented architecture applied to the database. And the easiest thing that we found to do, and we started Aurora 7 years ago, believe it or not, I'm still dizzy when I say that, is moving the logging and the storage layer out to a separate service. Not only that, you take an SOA architecture point of view, and you'd integrate with other services like EC2, like VPC, like Dynamo for key value store and management, Route 53, et cetera. And then you'd make it a managed service. And if there's one thing I'd love for you to take away from this conference this week, not just my session, AWS is about the software you write having everything it needs on the other side of an API. No humans involved. Our job is to teach software as developers to call other software. And that's the core power of AWS. And Amazon Aurora is built on that premise. So, why did we choose Postgres? Well, there's all these reasons up there, and I'm not going to insult you by reading you a slide. But it's an open source database. It's an enthusiastically open source database. And it actually has a higher speed of innovation than commercial databases. Now, I love my friends at Oracle. I worked there for 14 years. But the speed of innovation and the excitement I see on the PG Hackers list every day far exceeds that which I saw at Oracle when I was there. The open source community supports a diversity of opinion, trying things, failing at things, and moving ahead. Not only that, as you can see here, Postgres is by far the single most open source Oracle-compatible database out there. It's the most enterprise-compatible database. And you'll notice at the bottom, it has the highest AWS schema conversion tool rates from Oracle to Postgres of any of the engines. So in about 2011, we started working on Aurora. In 2014, we launched Aurora MySQL, and just 5 weeks ago, we launched Aurora Postgres. And I'm pleased to announce that after 5 weeks of data have come in, it is the fastest growing database service in AWS history. And that's not about me, and it's not about revenue, it's not about the size of my service. It's about customers taking the service and being delighted with it. So You can now choose it. You can now use it all you want. And we've been working with Ishii-san now for something like 9 months, and he's been an enthusiastic supporter of the product. And now I'd like to hand over the podium for him to tell you about his use of it. My clicker is no longer working, so I will go here. There we go.
Okay.
And if I need to be your clicker, I will be.
Thank you, Mark. Okay, and now it's my turn. I'm going to talk about performance tests made by my company, my colleagues. So could you proceed? Okay, here is environment. We have Amazon Aurora. Left-hand side shows the architecture of the configuration, and also I have Amazon RDS for the comparison. Each has exactly the same CPU spec, DDR3 X large, and also RDS has the same. And we have virtual CPU 32, and we also have 244 gigabytes memory. RDS is same as well. And we have each in the configuration 2 availability zones. One availability zone 1 for writer, and 2 is for reader. Same thing you can be seeing. You can see RDS master and replica. No, in this case backup. And later on, we configured this as a streaming replica. Anyway, so this is the third machine server, which is dedicated for transaction generator. We call it Pgbench. Maybe all of you are already familiar with. This machine has a larger number of virtual CPUs and also appropriate number of amount of memory, not to saturate the transaction generator load. By the way, Pgbench is a standard benchmarking tool coming with the standard Postgres replication. And by the way, I'm the original author of the small tool. Anyway, the intention of the configuration is, of course, we need to test Amazon Aurora, but to make an apple-to-apple comparison, I could set up the configuration with same CPU spec as well as the I/O provision, 10,000. This number is coming from the not purely technical reason, but rather than cost. We want to compare the approximately same cost configuration with Aurora and RDS. And at the time, Postgres 9.62 is the version. They are same on the both configuration. Next slide, please. As I said, the benchmarking is performed by using Pgbench. We employ a number of concurrent users, 250, 500, 750, and 1,000. And each concurrent number of connections, we perform loading data, creating index, executing vacuum for each test. This is because we needed not to remember the previous test memorized by the test. And the database size is 30 gigabytes. And in the configuration, the largest table, there are 200 millions of rows. And as you can see, here. This is the loading phase of the pgbench call. -I means initialize the database. And this one is actual transaction generation. We add progress equal 1. This is needed to take each response time for each transaction. And we choose protocol for prepared. This means that we use extended query, which is very popular in these days. Okay,
Yeah, there we
please. Next, please.
Hold on.
Sure.
I just disconnected him.
And minus large T 3600 means that the transaction will keep on for 3600 seconds. And also we have minus J option, which invokes threading. Okay, next slide, please. First, the graph is for loading data. I'm going to explain the rightmost bar. In the bar, all the bar, red one is RDS, and the blue one is Aurora. And the y-axis is elapsed time. So, of course, shorter is better. In the total time, elapsed time, RDS takes 3 times longer than Aurora. And the next, we are going to look through the each phase of loading data. Actually, this one consists of copy, vacuum, and indexing. Look at the leftmost graph. This is a copy. This performs basically transmission of data into the table. In this case, Aurora is actually runs at double the speed. The reason why this is just at 2 times faster than RDS is that the nature of the copy protocol, it requires each transmission for each load. So the network overhead is possible in this case. And the vacuum, you can see extreme good result for Aurora, you can see. The reason why this is that vacuum is just only one SQL command, but runs many IOs inside the server. That's why we get a very good result from this. And the indexing is not very good at Aurora because it's like a more CPU intensive load. Next slide, please. Here is the after the loading phase, we run the transaction load. We run the transaction load. The y-axis is a transaction per second. That means higher is better. And the x-axis is the number of concurrent transactions. We can see blue line, Aurora, is getting better and better with the increasing of the concurrent transaction until we reach the limit. It's about 750. On the other hand, RDS keep on decreasing the performance with larger concurrent transactions. So we can conclude that Aurora is better than RDS from 1.7 times to 3 times. Okay? This graph is somewhat interesting. This is the summary, details of the wait time, response time for each system. Aurora, as you can see, a very low wait time continuously with keeping stable state. On the other hand, RDS, you can see a large number of peaks. That means the wait time is not so stable. And if we look at this point, as you can see, for each transaction, there are variation of response time. This also indicates that the response time of RDS is not so stable. Next time, please. Oh, yeah, this is the conclusion. Aurora is much more stable than RDS. Okay, here is the, another data of the benchmarking. The left-hand side shows the Aurora's CPU utilization. Please note that the y-axis is different from Aurora is 100, while RDS is 40. So actually, Aurora is very good at consuming CPUs. That means there will be less locking overhead in Aurora. I think we can expect a detailed explanation later on by Mark. Okay? Okay, next. This is the IOPS graph. Yeah, left side, the y-axis is a little bit different from this one is,
It's 0 to 5,000 on Aurora and 0 to 10,000 on Postgres.
Yeah, a little bit different. Anyway, Aurora consumes lower IOPS than RDS. This means that this does not mean Aurora is not good at I/O, but has very different architecture for accessing I/Os. Okay. I think this is very important for production. In production, this is a comparison of replication lag delay between writer and the reader. As you can see, left-hand side Aurora, as the first time starting the benchmarking, the latency is high, of course, but at that time, after that, it's radically decreasing the latency and then keep on the low latency until the end of the transaction. About under 40 milliseconds, very low. On the other hand, RDS keep on increasing the latency and then never reaches to the consistent state. That means the particular load of the transaction is too high for RDS in this case. Okay, next slide, please. Finally, I'm going to give a short summary of the benchmarking. In summary, I can say that Aurora is 3 times faster than RDS. This is very good news for Postgres users, I think, because for my long experience with Postgres development, I know that increasing the writing speed is very, very difficult in the relational database system. So I was really surprised by the number after finishing the benchmarking. And also, throughput is 3 times better than RDS. And then this is very, very important. We got very stable response time during the benchmarking with Aurora. And I need to talk about the tendency with increasing the concurrent transactions. Aurora is very good at handling large number of concurrent transactions. And finally, I have to say that Aurora is very good at decreasing the replication delay, lag. This is very important in the production system. So also in overall, I got very satisfied impression with Aurora. Thank you.
Thank you. My clicker is back. So there's some big questions that come out of that. First off, how real are those numbers? Well, Ishii-san is one of the Postgres committers, ran these numbers for months and kept getting consistent results. There's a presentation at this session where we're giving Aurora Postgres numbers, and you'll notice those numbers are lower than the numbers that Ishii-san just shared with you. I can tell you why. When we run benchmarks for publishing at a conference like this, I take the absolute worst numbers that Aurora Postgres gets and the absolute best numbers that RDS Postgres gets. And that's the multiples you'll see on our slides. At the same time, these are awesome numbers, and we're really happy with Ishii-san for running them. So now the question is, can you get this kind of performance? How do you get this kind of performance? And can you get it while getting high durability and availability? So let's first talk a little bit about performance. How do we achieve high performance? Well, fundamentally, the best way to achieve high performance in computers is to do nothing and say you're done. And so that means do less work, minimize network packets, offload the database engine. That was one of the things that Ishii-san showed about the database engine actually running less instructions per PG-bench transaction than RDS Postgres did. The actual CPU was higher, but if you did CPU per transaction, it was significantly lower. Next, databases are all about I/O, so optimize I/O, and I'll get into that in a bit. Next, make sure that you do things asynchronously in every single way. So how does I/O happen in an Amazon Aurora database node? Well, the storage system is that separate storage system I told you about. It's actually spread across 3 AZs with 6 copies, and it writes to all 6 copies. Now you may say to me, oh my God, Mark, that's 6 times the writes. But there are no blocks written from Aurora Postgres. None of those 8K data blocks are written at all. What might be written are 100 byte or 40 byte or 250 byte single row wall records. The storage system takes care and is absolutely aware of exactly how Postgres works and applies those log records to the blocks on the database system, on the storage system. So there's 9x less network traffic on most of the workloads we've looked at. To tell you the truth, this is another Amazon conservative number. It's actually better than that on many of our customer workloads. So one of the things that Ishii-san talked about was read replicas. Why do they have higher reliability, lower lag, etc.? Well, the reason is because in Postgres on the left, you'll see that we do, normal wall apply. We stream the data over. It gets applied. So if there's a wall record that needs to be applied, it actually has to go read the block from disk. It has to apply the wall record. It has to do all the checkpoints. In many ways, the replica in Postgres is doing exactly the same work for all writes as the master. Obviously, it's doing different reads, or why do you have it? In an Aurora scaling system, because there's shared storage, you'll notice that the Aurora master is doing fundamentally the same thing, but the replica isn't. The replica is getting the page cache updates coming across, and when it finds a page cache update for a block that has not been modified on the replica, it tosses it away. It doesn't do anything with it. It doesn't care. That's the vast majority of writes that come across, which means that Aurora replica can actually process many, many more reads for you and be more efficient. In addition, the second really fun part about it is that because that page cache update is a very simple protocol, that's how we get to sub 20 millisecond lag times and averaging around 10 to 12 millisecond lag times between Aurora masters and Aurora replicas. And I'll point out that lag time stays almost consistent even with up to 15 replicas. It might go up to like 30, 40 milliseconds, even with 15 read replicas running at the same time. So what's the core of the innovation? The core of the innovation was parceling out the storage system into a separate node. And as a database guy, do you know what I want? I want my database to just keep doing transactions. So one of the ways we keep doing transactions quickly is that the only thing which the head node waits for is items 1 and 2 on this sheet. It only waits for the redo log to come in and be persisted to SSD. That's it. All the other things you see going on in the storage node happen completely asynchronously and take no CPU time from the head node, i.e. your database node, which includes identifying gaps in the log, gossiping with peers to fill in holes for durability, coalescing into data blocks, because data blocks do exist in Aurora, they just exist out on the storage system. Garbage collecting old versions, running 24/7 CRC checks and validation checks on the system. These are all done with leftover CPU time. And then there's another thing happening in the storage system. All backups are done from the storage system. There is no backup that occurs on the head node, which means that your head node, wait for it, just keeps doing transactions. So now that you've done all this, how do we keep it durable and available? I've talked a little bit about it being replicated 6 times across 3 availability zones. The data is backed up as it comes in directly to S3. It's backed up into 10 gigabyte segments for repair, and there's a whole talk about why we chose 10. I won't get into that now. It was a pretty careful balance we chose. It has to do with network I/O speeds and mean time to repair and all those. It actually has something pretty cool I'll get into in the next slide, which is it uses a quorum system for reads and writes. And again, when the quorum membership changes, it doesn't stall reads or writes. And I'll get into that. And it supports up to 64 terabytes. So this is just a quick slide that shows the architecture again. You can have a primary database node. You can have read replicas in your own AZ, that's fine. You can have them in other AZs if you want, up to 15 of them. And all those blocks are scattered across all those availability zones. Well, the reality of the world is things break. And at the scale we run AWS, no matter how hard we try, things break pretty regularly. While I'm standing here running RDS and giving this presentation, we've had nodes fail over in the fleet, and my phone has not gone off. And that's important. I get paged when a failover fails. So what can happen? You can lose a disk, that's the little baby X's. You can lose a node, that's an entire machine. Or, God forbid, you could lose an entire AZ. We've never done that, but it could happen. When the head node does its writes, it only waits for 4 of the 6 to come back. And then it tells the head node it's good. You can go ahead with your transaction. 2 key features. Number 1, you can actually lose all those things I talked about. And when they come back, the system will go and repair itself. All those arrows you see between the purple boxes are the system repairing itself if it missed a read or if it missed a write. Or if, let's say, an AZ went away for 10 minutes. Next, what is the single largest cause of performance problems on databases that can be attributed to hardware? It's actually jitter. Applications perform very poorly in the face of jitter. They get all queued up, they start asking for more connections, they run out of memory, they do all sorts of stupid stuff. Well, if you take away 6 writes, and you take away the 6th one, which is the slowest one, and you take away the 5th one, which is the 2nd slowest one, jitter on Aurora Postgres is 13.6 standard deviations less than jitter on RDS Postgres or Community Postgres. And we have data that backs that up in another presentation. Here's another way of looking at replicas. The replicas can be across AZs, they can even be in your own AZ, and they automatically are promoted to the master. You don't have to do anything. They're promoted to the master, the DNS endpoint is moved over. Because we own the database engine, we actually have been able to make changes in the database engine and in the RDS control plane that actually means that our failover times are about half as long as RDS Postgres. And we're working very hard to make them less. In fact, in Aurora MySQL, our sister product, they have regular failovers that take less than 10 seconds. And if I was writing a commercial database multi-node product potentially called RAC, which I did, I was one of the architects on RAC, customers have told me for 30 years, if you can get failovers to less than 10 seconds, I pretty much don't need RAC. Now, we're not there yet, but that's what we're working on. So now I'd like to hand it back to Ishii-san to talk about Pgpool.
Thank you. Now I'm going to talk about the Pgpool-II, which is maybe new for most of the audiences. Is there anybody know about Pgpool-II? Wow, amazing. Thank you very much.
Do you want the slide? There you go.
Okay. For those who are not familiar with Pgpool-II, I'm going to give a brief architecture of Pgpool-II. We have a client, of course. Oh, sorry.
Do you want me to be your slide again? You're going the wrong way?
Oh, sorry.
Is that what you want?
Yes.
Okay.
Thank you. We have a database client here, and also we have a database right-hand side, and in between them, we have a Pgpool-II. So Pgpool-II is kind of a proxy between database client and the database servers. This architecture can be also applied to Aurora, I thought. So I made an experiment. I did some experimenting test with Aurora plus Pgpool-II. Anyway, in this case, Pgpool will behave like a query dispatcher. I mean, write query must go to the writer, while read queries can be routed to either writer or reader. This is kind of load balancing. So in this case, there are two merits for database users. One is they don't need to care about the distinction between write query and read queries. And the next one is load balancing. If they are not satisfied with the read query performance, they could add read replicas as much as possible to get a higher performance. And at that time, we were doing the tests. We also are in the phase of developing a newer version of Pgpool-II. And I decided to make the newer version of Pgpool-II deal with Aurora. So I'm going to announce that the newer version of Pgpool 3.7 is available this month. Actually, that was 22nd. We have we can buy Pgpool 3.7 with Aurora that including automatic distribution of queries, like I said, and we also we could deal with Aurora by doing some configurations. We also include detailed step how to set up Pgpool-II for Aurora in the documentation. And as usual, Pgpool-II can provide functionality such as connection pooling and query caching for Aurora as well. So please enjoy Pgpool-II and Aurora with a newer version of Pgpool-II. Thank you.
We are very, very excited about Pgpool-II. We're excited about the support for Aurora. Obviously, it already supports RDS Postgres and EC2 Postgres if you choose to do that. And I'd love to see more hands up next year. So now I'm going to talk about performance insights. So for all of you who raised your hands for RDS, if you've used it before 2016, it was hard to see what was going on inside RDS. So we released enhanced monitoring. Enhanced monitoring let you see on the console or through the API 53 OS statistics, such as the things you'd see in top VMstat, IOstat, etc., down to granularity of 1 second, and you could actually look at them back in time, something you can't do with VMstat and IOstat. So you could, for example, determine that something went wrong 3 hours ago and see what it was. Well, customers love that, but then what they wanted to do was they wanted to see inside their databases. So now we're offering performance insights, and this went into preview on October 24th at the same time Aurora Postgres went into GA. So this was the enhanced monitoring I told you about. And Performance Insights basically is trying to help you understand in a GUI way on your screen what's going on inside your database. And we're going to release it over the next year, next 6 months rather. It's coming out on Aurora Postgres now. It's on Aurora MySQL real soon now. And then it's going to be on the other databases that RDS supports through the first half of 2018. All RDS databases will support Performance Insights. Obviously, some of them will support it better than others. For example, Oracle, which has a truly amazing set of statistics that can be got in real time, will have a really good support for Performance Insights. So what is database load? Well, if you think about what's loading a database, fundamentally there's two things. You can have everyone doing work and run out of something, or you can have everyone not able to do work and wait for something. And so every second we sample what SQL is going on, what the state of that process is, and what host it's coming from, and what user it's logged in from. And this is what the dashboard looks like, except I don't really like dashboards. I'd rather actually give you a video. So let me switch here to giving you a video.
Today, I'll walk you through how to access and use the Performance Insights dashboard. To access Performance Insights, click on Instances in the top left. What I want to bring your attention to is a new column called Current Activity. In this case, we have one database with high load. Part of that load is in the red state. So let's click on that bar, and it'll take us to the Performance Insights dashboard. The Performance Insights dashboard is divided in two parts. The top part shows a load on the database over time. And the bottom half shows the top SQL ranked by the amount of load they're putting on the database. And in this case, we can see that some load has spiked up in the past few minutes, and it says color yellow. Now what is yellow? We can look at the legend to the right, and I see yellow is CPU. So it looks like we're having CPU starvation. Now how do I identify the bottleneck? We identify the bottleneck by looking at this dashed black line, and that represents the number of cores on the machine. We can only have as many sessions running on the database as there are cores on the machine. And if the load goes above the dashed black line, the number of cores, then we know that we're waiting for something. Now that could be CPU, or it could be other resources, such as locks, I/O, commit writes, or others. Now where is that load coming from? We can look at the top SQL on the bottom. And in this case, our load saturation is coming from CPU. So we want to find the SQL statements that are consuming the CPU. In this case, the only one that looks like it's consuming much CPU is the third line down, all in yellow. It's a select Pgpool-III. Now I know as a DBA that it'd be worth my while to spend a day tuning that SQL statement, in this case it's a procedure, to cut down on the amount of CPU it's using and eliminate the CPU saturation on this instance. Now I can zoom out to larger time frames. If I click on 6H, that's 6 hours. And in this case, I see that there are spikes earlier. Now I can select a spike by clicking my mouse and dragging across the spike. And now I'll zoom into that load period. And in this case, I no longer see CPU saturation. I see some other wait event. So we're waiting for something. Now I can look into the legend, and I see the top wait event, blue, is IO:XACT sync. Now, we can look up the definitions for this wait event, and it turns out this wait event is waiting for writing changes to the database to stable storage. Now, what SQL statements are waiting for this? I look in the top SQL, and I see the first two statements are the ones spending almost all the time waiting for this. Now, what are those SQL statements? Those are insert statements, which makes sense because we're waiting for changes to be written out to stable storage. In this case, I see that the insert statements are inserting, the first one inserts one row into the table at a time. And what happens is by default, we have implicit commits. So after every insert statement, we have to wait for a commit and guaranteeing the changes are written to disk. Now, if I want to optimize my application, what I could do is have insert statements that do many rows in one single insert statement. Now we can look at the data with other dimensions. So by default, it's weights on top and top SQL on the bottom. But on the bottom, I can also choose to look at the top weights, which is the first one, and see which weights I've spent the most time on. We've already seen SQL. I can also see it by hosts. In this case, I have two hosts, and I can see that the load is well balanced across those hosts. Now, if I had an application server that might have had the wrong version of the code on it, it might be taking up higher load. and I can see immediately across my application fleet if any of those instances are generating higher load on my database. I can also click on users and see which users are putting the most load on the database. In this case, my application is running all as one single user. We've looked at the top table on the bottom half of the dashboard by different dimensions. We can also use those same dimensions on the load chart on the top. So if you look at the legend, to the top right of the legend, there's a line that says slice by. By default, it's weights. I can click on it, see other dimensions I can group by. So I can, instead of weights, choose SQL. Now the load on the database is exactly the same in the chart. What we're changing is the stacked colored areas. So the stacked colored areas were weights, and now they're SQL. So I can see the load by SQL over time. So for example, those SQL waiting for the rights to stable storage were not steady state. They came and went. Whereas some other SQL statements had a very stable load on the database. I can also do it by hosts. Now we saw that we have two hosts that look like they were putting on similar load onto the instance. In this case, we can see one host had a steady state and another host put on a heavier load during a certain period of time. And finally, we can see the load by users over time. In this case, we just have one single user. So we've seen how Performance Insights makes it easy to see the load on an RDS database and to both identify when there are bottlenecks and where to act if there is a bottleneck. Thank you for watching.
So what do people think? Is that pretty cool? It's something that I've wanted to write for 30 years in databases, because at Oracle, I spent a lot of my time having customers tell me their database was slow, and it's like, well, is it slow now? No, but it was slow on Tuesday. Oh, well, is it slow now? Well, yes. Well, when did it start getting slow? I don't know. With this, you can go back and you can say, hey guys, it started getting slow Monday at 12. Can you guys please look at your Git log? Because I bet you deployed something Monday at 12. You can, just in the preview, when we had 4,000 customers using Aurora Postgres, about 1,000 of them used Performance Insights. And we're very quickly able to come up with what was going on in their database. And I won't tell you what the previous name of the project was, but they kept using the word insight when they were using the product. So we renamed it when we launched it to be Performance Insights. So I'm going to spend 1 or 2 minutes just diving a little bit into the methodology. So the first part is that it samples every second. And so if you think about a fast query, which is run rarely, we're probably not going to catch it. I mean, that's the reality. We might catch it, we might not. If you think about a query that's run pretty often, we'll catch it. And if you think about a slow query, well, of course we'll catch that, because we'll catch it doing things. So sampling is like film. It's awesome because you can see exactly what's going on, but you can only see exactly what's going on every time you do a frame. So let's look at how it might stack up your active sessions. Your sessions, your users might be waiting on things or loading things, and it stacks it up into this active sessions graph. Because at the end of the day, in databases, what you really care about is finding out who the bad guy is. It's not about all the good guys. And that's why when you saw that video, the drilling in was always to find out what was different. And so here's an example where there's different queries going on over time doing different things. And then this is an example of how the system stacks those up. Now here's kind of a fun thing. We believe in eating our own dog food. Remember how I told you how the beauty of AWS is that everything lives on the other side of an API? Performance Insights uses 13 AWS services in its use as internal services. Elasticache, Dynamo, Redshift, all these other services. All of those aggregations you saw, there was no speed up of that video. That's in real time. And we can do this across the RDS fleet, and it is turned on by default when we launch it into GA for every single user. So you can go back and look at this by default. If you want to, we'll have options. We're not quite sure how yet. We'll have options where you can go back farther and farther in time and take a look at what happened 30 days, 60 days, 6 months ago. You can look at what happened at last quarter close in your financial database, because hey, it wasn't bad like this one is. So we've already shown you how you access Performance Insights. You just go right there on the console. It's available. It shows you databases right there with that new column called Database Load. You just click through, and all of a sudden you're there. So in another part of a presentation I gave earlier today, I gave out the email address of Aurora, and I forgot to put it in this presentation. It's aurora-pm@amazon.com. For PI, it's rds-pi@amazon.com. And if any of you have comments, questions, feature requests, etc., feel free to reach out directly to that email address. So now, I'd like to move on to questions from the audience. Does anyone have any questions? I don't think, do we have
Over there?
walkabout mics?
About the discussion is about is for the Ishii-san. So about the performance difference. So you mentioned copy, vacuum. So it's a lot of difference. I just want to know more insights, internal reasons you explain. Maybe a little bit more details.
Which one?
For example, the copy and the vacuum.
Okay.
Yeah, why Aurora is possible.
Okay. As I can see, copy is that comes from the nature of each operation. Copy consists of actually a number of network transmission. Actually, one transmission for each row. So if we have 200 million rows to be filled, you need to send out 200 million packets to the server. That's the reason why Aurora is not so good at that point, because Aurora is does not make any enhancement for network handling in the database system. And on the other hand, vacuum consists of just a single SQL query. That means it only requires one packet transmission from the client to the server. And as soon as the packet arrives to the server, a server has to do the very heavy I/O intensive job, which is vacuum inside. So if Aurora is very good at I/O, then you can see the very much difference from RDS between Aurora and RDS. So you can virtually eliminate the overhead of network transmission. And finally, create index is a very, very I/O intensive job because it needs large number of sorting rows inside. That is, in this case, as I said before, this particular server has much memory that was over 200 gigabytes, which is much larger than the actual database size, which is only 30 gigabytes. So all of the operation is performed inside in memory that does not consume any I/O, so which is a purely CPU intensive job. That means Aurora is not so, will not show better performance in this case. So is this answer to your question?
So we also have Grant McAllister. Can you stand up? Grant McAllister is the founder of RDS and our senior principal engineer. Okay. I wasn't actually going for applause, but he does. So Grant has been with Amazon for almost 20 years and lived on the retail side and decided to take all the learnings from the retail side and brought it over to AWS to write RDS. So Grant?
So I was just going to say, we have another presentation tomorrow at 4 p.m.,
Right.
DAT316, which is mine, where we're going to actually dive into a lot of the very specific changes and how they affect some of these things like vacuum, the changes we've made there. So, around the difference in logging and get really into the deep details on how that makes these numbers happen. So, just more details if you have time tomorrow.
Other questions? I will point out one thing before you ask other questions, that I brought stickers as kind of a bait to come up and ask questions afterwards. So they're all here on the podium. Are there other questions? Yes? Yes?
Will performance insights require any changes to Postgres RDS, any changes to transaction or parameters?
So the question is, will Performance Insights require any changes to RDS? And the answer is no, not at all. Not at all. Now, it may make you want to make some changes, but that's a different thing. Okay, other questions? Right here? If we could turn the house lights up, that'd be great. If not, that's okay too. Yes, third row?
What's the overhead on getting sampling data for performance?
So that's a great question. We learned a lot with our enhanced monitoring product in 2015 and 2016. And right now, the performance overhead, at least on Aurora, is running around 1% to 2% to do the sampling. It's a great question, by the way. I should put that in my presentation. Back in the maroonish shirt or dark shirt. Yeah. Yeah, you're lined up. So the question is, what extensions are supported for Aurora Postgres? So I'm going to give you a number of answers. The first answer is Aurora Postgres and RDS Postgres will have the same extensions. We will keep extensions parity between the two releases. The second question, between the two products. The second answer to your question is that they're all documented on the RDS website. And I think, Grant, we have probably 25 right now?
57.
Okay, see, there you go. That's why I bring him. That's why I bring him.
That includes three logical decoders, so really 54 real extensions.
Okay, so now be clear, typically as the GM, I'd say 112, and he'd say 57. So I screwed that one up. Okay, and so it's a long list. Now, remember I told you about Aurora-PM? We are very, very excited about adding new extensions to both RDS and Aurora Postgres. And if you need an extension that's not there, reach out to us, because we have so much work to do to add extensions in the right, safe, performant way that we have to make some Hobson's choices sometimes. And so when we hear more customers want one than another, that literally affects our choices. More questions. There, fifth row. Yes.
Okay. I have a question about Pgpool and Aurora. The way I saw on these diagrams, more concurrency we have, the performance is better, right? More throughput is better. So does it make sense to aggregate connections through Pgpool when you have a whole fleet of services using the same database? Or it makes sense to leverage more connections to Aurora?
So, do you want to answer that, Ishii-san? So the question is, using Pgpool, would it make sense to not use Pgpool and have more connections? Or would it, here's what we've seen, is that most applications kind of have a sweet spot in the number of connections. And one of the things you really want to avoid is connection storms, where something gets slow and you slam your database. So we think that Pgpool is a great tool to control the number of connections to your database.
Yes.
And you know, so what we've seen people do is kind of dial in the right number of connections for their application. Now that being said, an awful lot of people just run raw connections direct from their client into their database. However, some of the other things Ishii-san talked about Pgpool are compelling reasons to think about using it as well. So, I want to kind of be fair. Are there any on the sides? I've been always middle. Yes?
Quick question. I think you mentioned earlier about a roadmap to Postgres 10 for Aurora. Are y'all letting know that big for a while, or should we hear news soon as to when you think that would you be projected to have that support for 10?
So by the way, I will point out that the asker is a member of the Postgres community and has very biased reasons for asking the question. Thank you. And exactly, and thank you for asking. So, and I did not plant the question. So the answer to that question is we are trying to get our times for releasing our lag behind the community down to 30 days. Right now that's aspirational, and we're not there yet. Our preview was a little bit longer for GA than we thought, but you can see us trying to bring that closer and closer. We have Postgres 10 compiling with Aurora right now. We actually pulled some of Postgres 10 back into Aurora Postgres 9.6. And loved it. So we're going to be looking to make it as quick as possible. At this point, we're looking to probably skip 10.0, which I bet most of you are probably going to do the same thing, and release 10.1. And stay tuned on there's an Aurora Postgres forum. Stay tuned on that forum for more dates.
Any plans to contribute back to the mainstream Postgres edition on the learnings and improvements and optimizations?
So the question was, are there any plans to contribute back? And the answer is we already are. 2 years ago, Amazon was not as vibrant a member of the open source community as we liked. We're changing that. We now have Adrian Cockcroft, who's come and joined us. He's VP of Open Source, and he came from Netflix. We actually, 2 to 3 weeks ago, I believe, launched opensource.aws.amazon.com. Go check it out. It's got a lot of resources. It talks about what communities we're in. It talks about where we're putting our energy. That's the wider AWS answer. The narrow answer from my team is, as of a couple months ago, I now have people on my team who are spending their time building things to contribute back to the community. We are changing in that regard, and stay tuned for more and more and more. We are deeply passionate about the Postgres community and deeply passionate about contributing to it. Question, I gotta do the side, sorry.
The Pgpool sounds like a great addition, but it also sounds like something that I might then have to manage. Will that be included as part of RDS in the future?
So you're not the first customer to ask that. We're talking. And that's the answer.
Yeah, this question for Ishii-san. So this Pgpool, it will handle this consistency because the reader the read replica can have some delay, right?
Yes, actually there is a configuration parameter which handles how much replication delay between master and slaves. If that is too much, then Pgpool will automatically reroute the query to the master to avoid the replication delay.
So this read delay is really an issue to customer, or customer think it's totally okay if they get some old data?
I think that depends on the application. If applications has been developed under single database server environment, probably the application does not suppose that there is a delay between update and select. In that case, replication delay will be a serious problem for the application. So in this case, I would say replication lag is very important.
Okay, there's a question here in the center with the glasses, I think. Yeah.
Just a question. So this looks awesome, but why would I use the RDS classic Postgres? What's the reason?
So the question is, why would I use RDS Postgres? I will avoid repeating the word classic. And what I'd like to say there is there's a lot of good reasons to use RDS Postgres. It's a great platform. It's the community code. It's a great piece of software. You might not need all the durability, availability. And there's another thing to realize. There are many, many apps out there which are not highly concurrent. Everything I've talked about on the performance side has been about highly concurrent applications. You might have an application where you're running a WordPress blog. I don't think I'd really go to the effort of standing up Aurora Postgres versus RDS Postgres. It does cost more, slightly more on the console, though we believe it is more price performant because you get far more transactions, as you saw. But there's a lot of reasons to use RDS Postgres. Remember I told you that Aurora Postgres was our fastest growing database product? What do you think our second fastest growing database product is? It's RDS Postgres. And there's no sign of that slowing down. Other questions? There.
This is more of a SQL layer question. If I have lots of articles or procedures in Aurora, are you going to someday do something that I can just, with minimal developer support, just migrate from one to the other?
I didn't pay him either. So about 2 years ago, I was the general manager of the database migration service and the schema conversion tool. And the schema conversion tool is a tool which will scan your database, often Oracle, though not all the time by any means, and it will look at your triggers, constraints, schema, indices, sequences, and PL/SQL. And it will give you an assessment report right there of what will convert and won't convert. What happens from that assessment report, and by the way, Postgres is the one engine which converts best from Oracle, to use an example. What happens with that assessment report is you can use it to figure out what work needs to be done. We've seen databases get as high as 100% if they use simple things and don't overuse PL/SQL. We've seen databases get as low as 50%. It's all based on your usage. But what you do get is you get someone to tell you how much work there is, at least at a high level. Now, the other thing to notice is that that tool actually anonymously records what things failed. Like, say, a sequence couldn't be converted, as an example. Those sequences can now be converted. It reports it back to the dev team. And I'll give you exactly one guess as to what the dev team uses as their largest input to their backlog for the next sprint. They use what things are currently not being converted well in the fleet. So there's a product that's there now. I'd advise you to go look at it and realize that over time that product will get better and better. I will also say that there is nothing about database migration that is easy. It is hard, and we will be here to help you with it, but it's a hard journey we all need to make together. And that's from any platform to any platform. White shirt? And then I actually think we're going to take this last question, and then we're going to move off stage to down here, and that's where the sticker bait is, right on the podium. So last question.
So to migrate from Postgres, do we have to migrate to the 9.6 version? If we are having an older version of Postgres RDS?
So right now, Grant, you need to migrate up to 9.6 in RDS Postgres using major version upgrade feature, and then you can move directly into Aurora Postgres from there. So, yes. Okay, thank you so very much. Please fill out your session ratings so we can know what to do better next year. We really appreciate it. And for those of you who want stickers, come to the side of the stage.